So you might be thinking this example is just like the previous example because we have letters and numbers underneath here. But then you start to do it, and then this part might trip you up. But let's just kind of review the parts that do make sense. This 50, I'm going to break it up according to one of these perfect squares if I can. And 50 is 25 times 2. So that's cool. I've got a part I can square root and a part that I can't square root. This x to the 8th, I kind of started thinking about that over here a little bit. And you're probably thinking x to the 4th would be good there. But now this y to the 11th. See, that's problematic because we're not going to be able to use some kind of weird decimal here. You know, I'm not going to put a 5.5 in there. What I can put in there, though, is a 5. But the problem with that, of course, is that this is not going to equal y to the 11th. It's going to equal y to the 10th, you know? So, but if you get that this equals y to the 10th, and you also understand that y to the 10th times y equals y to the 11th, then you're actually in really good shape right now. Because what I can do, and if you don't understand that, the idea here is if I have y to the 10th times one more y to the 1st, that would be y multiplied by itself 11 times, that would be y to the 11th. So if I actually want these sides to be equal, I'll slap a y on this over here as well. Now what does that do for us? That tells us that, if I go back to the original problem, this becomes a 5, and that 2 is trapped inside. This x to the 8th becomes an x to the 4th on the outside. And this y to the 11th, I'm going to think of that as y to the 10th times y. So now I have a part that has an even number on it, and I can deal with that. X to the 4th, y to the 5th, and the square root of 2 is left inside, and y is left inside as well. So basically, if you have an odd number, break it off, just break one off, so you have an even number and then just one more, and then divide the part that you can. Good luck.